Hi, welcome to chemistry class with Emerald. And today's class we are going to be looking at the covalent bond and of course the coordinate covalent bond. This video is brought to you by Agotha Virtual Learning. So our major focus for today's class will be the covalent bond, the factors that affect covalent bonds, the types of covalent bond that we have, and of course we are going to be looking at the coordinate covalent bond and how it differs from the pure covalent bond. What is covalent bonding? Covalent bond is a bond that happens between non-metals. It involves sharing of valence electron between atoms, or what we call electron clouds overlap. So in covalent bonding, atoms or electrons are shared. In covalent bonding, electrons are shared. When compared with ionic bonding, where electrons are transferred between metals and non-metals. In covalent bonding, electrons are shared between non-metals, and of course there is electron cloud overlap. Examples of covalent bonds include, or examples where covalent bond exists includes H2O, CH4, glucose, ammonia, and CO2. Okay, let's look at types of covalent bond. Atoms can be shared in terms of single, double, and triple covalent bonds. That means we have single bonds, double bonds, and triple bond. Each bond represents a shared pair of electrons. What do we mean by that? What we mean by that is that two electrons equals a bond. That means that, for instance, in hydrogen, the first hydrogen atom is donating one electron and the second hydrogen atom is donating another electron. If they combine together, they form an hydrogen molecule, the HH bond, HH single bond. We have other examples like that of that is found in chlorine. The valence electron for chlorine is 7. If you are using the Lewis dot notation to draw it, you are going to have 2, 2, 2, 1. Then the second chlorine atom 2, 2, 2, 1. So they are going to use the 1 each. Don't forget that there are choice the one that is remaining, they are going to use it to bond. So one chlorine will drop 1, the second chlorine atom also drop 1. So you are going to have the 2 in between them, and it's going to be chlorine bond. But you leave them with the shared pair will now become 1, while the unpaired electron on each of the chlorine atom will be 3. That's the lone pair of electrons. So chlorine also will form Cl single bond, and then we can also still have HCl single bond. So these are examples of single covalent bond. In terms of double bond, you can have oxygen molecule. Now in oxygen molecule, you have a 2,6. So for the 2,6, for the 2,6 on oxygen molecule, you are going to have the lone pairs, 2 lone pair on oxygen atom. You're going to have 2 lone pairs of oxygen atom on each oxygen atom, and they're going to drop 2 electrons each for bonding. So you are going to have 4 electrons at the middle like this. And of course, like I've said, 2 electrons make 1 bond. So 4 will make 2 bonds. So we have oxygen double bond. You can also exist between CO2, where CO2 C carbon is at the middle, then it's bonded by 2 oxygen in terms of double bond each. So you have For oxygen molecule, you have a OO double bond. Then we can have also triple covalent bond. An example is nitrogen. You have one lone pair on that nitrogen atom, the other, because oxygen is 5, so it will drop 3 for sharing, and then there will be a lone pair. That means lone pair means two electron will be on top of each nitrogen atom, so 3 will be used for bonding. So when the first nitrogen atom drop uh, 3 electrons, the second nitrogen atom also got 3. So 3 bond making 6 electrons will make 3 bond, 2 for each. So you are going to have nitrogen molecule having triple covalent bond. And of course, you will also observe that uh, the these bonds are usually existing between um, atoms of the same element. So sometimes we call it homonuclear covalent bonding. Why is it homonuclear covalent bonding in all of this? Because for each of them is the bond is existing between atoms of the same element. However, it is also possible for it to exist between atoms of different elements. Like I've said, ACL. ACL will form a single covalent bond. You could have H2O, will also form a single covalent bond. You can also have a NH3 as the case may be. So those ones are called, they are existing between atoms of different elements. So they are called heteronuclear covalent bonding. But all of these are still under covalent bonding, as you have said. So these are the types of covalent bond. Okay, now let's look at some of the key factors that affects or that affects covalent bonding. We have differences in electronegativity. For covalent bonding to occur, the difference in electronegative value of each of the element each of the atom combining together must be smaller than that of the ionic bonding, and is usually less than 1.7. What do we mean? What we mean is that the difference must be small. For instance, in a combination of ACl, which is a covalent bond, and like I've said, it's a single covalent bond, it is heteronuclear now. You observe that hydrogen has covalent electronegative value of 2.2, then there is difference in electronegative value. Hydrogen is having 2.2, chlorine is having 3.2. The difference is 1.0, less than 1.7. So the difference is electronegative value. For covalent bonding to occur, there must be difference in electronegative. The difference in electronegative value of combining atoms must be very small than that of the ionic. For instance, in ionics, the difference electronegative is always large because metals is combining with a non-metal, so it's always very large. But in covalent, it must be very small, and then must be usually less than 1.7. Now another factor is bond polarity. So when we now look at polarity, as the case may be now, we can now see we can have polar covalent bond and then non-polar covalent bond. Now when we talk about polar bond occur when there is a difference in electronegative value, and usually it involves unequal sharing. For instance, in hydrogen chloride, for instance, it is a polar bond because number one, it has two poles. Two poles in the sense that hydrogen is positive and chlorine is negative. In this case, a polarity is established. In this case, so and then the difference in there is always difference in a salient difference in um, electronegative value. For instance, uh, electronegative value of nitrogen is 2.2, chlorine is 3.2. So the charge difference is created among them. So they are going to be a polar covalent bond. They are having also two poles. So we have bond polarity, and then we have non-polar bonds, and that's non-polar covalent bond. Now there is no difference in electronegative value. So there is no difference in it. For instance, O2O2 will have OO atom will have the same electronegative value. That means that all of them are diatomic. So all diatomic uh, molecules or diatomic elements will have a non-polar covalent bond. So what is a polar covalent bond? A polar covalent bond is a bond in which there is a difference in electronegative value of each atom combining, while a non-polar bond is a non-polar covalent bond is a bond that exists because there is no difference in electronegative value of combining atoms, and then there is equal sharing of electrons. Here there is no equal sharing of electrons. So you can have, in terms of polarity now, you can have polar covalent bonds and non-polar covalent bonds. Please take note of that. And a non-polar is usually between the atomic elements. Okay, so let's look at molecular formula. Covalent compounds are molecules. Take note of that. Covalent compounds are usually molecules. Therefore, they are going to have a molecular formula. This molecular formula shows the actual number of atoms in each element present in the compound. This molecular formula shows the actual number of atoms present in each element of in a compound. So, for instance, in nitrogen now, it's clear that we have the molecule because they are molecules. They are molecules. Covalent compounds are molecules. In hydrogen now, it shows that we have two hydrogen and one oxygen atom combining together. Okay, so of course, covalent compounds usually also have, apart from molecular form, because they are molecules, they have molecular formula. They usually also have a structural formula. Structural formula will show us how the atoms are bonded together in a covalent molecule. It shows how the atoms are bonded together in a covalent molecule. And so we usually use lines to show the covalent bond, and an example is given there. Okay, so let's look at few properties of covalent compounds. Number one is melting and boiling point. Most covalent compounds have low melting and boiling point, especially ones that is usually lower than the ionics. Why? Because if you want to melt or boil, you are only separating the weak bonds between the molecules, not within the molecules. If you are melting, you want to separate. Melting or boiling involves you separating the weak bond between the molecules, not within the molecule. So the energy that you are going to use to do that will be low. So most covalent compounds have low melting and boiling point. Now for polar molecules, however, they might have a slightly higher melting point than the non-polar molecules because they are harder to separate. There is an active dipole-dipole interaction which will require energy for it to be broken. So higher polar molecules or polar covalent compounds, e.g. HCl that we mentioned, we have slightly higher melting and boiling point than that of non-polar molecules. For polar, in terms of solubility now, that's another property of covalent compound. Polar molecules now, for example, HCl, H2O, NH3 will dissolve in polar solvent. This is a rule of solubility. Like dissolve like, and of course that means that polar substance will dissolve in polar solvent, while non-polar substance will dissolve in non-polar solvent. Polar molecules like ammonia and the likes will dissolve in polar solvent. An example of polar solvents is also water itself. Then why non-polar molecules, e.g. Ethane, CCl4, and etc. will also dissolve in non-polar solvent. An example of non-polar solvent now will be um, ethanol, can be kerosene, petrol, etc. Even an example of polar solvent is water, dichloromethane, and of course ammonia. So polar substances like HCl will dissolve easily in this polar solvent. Non-polar solvents like fats, like organic substances, will dissolve in these non-polar solvents that we have mentioned here. So solubility is also important. And then for covalent, another property we look at in covalent compounds is conductivity. Covalent compounds do not conduct well because they do not form ions. Polar molecules do not convert well because they do not form ions. The exception to this case are the acids. The acids are covalently bonded, but in water they will ionize and conduct electricity or current. Why? Because acids are generally polar covalent compounds. Some of the acids are polar covalent compounds. For instance, HCl, they have two poles. So because of the presence of the two poles, they can conduct electricity. But outside the polar, uh, outside acid, most covalent compounds do not conduct electricity well because they cannot form ions. So another property is that is the composition. If the heat gets high enough, covalent compound will break down and decompose. If the heat gets high enough, the covalent compound will break down and decompose. An example is the sugar melted first, then it burn and turn into black carbon. Sugar is an organic substance and of course is a covalent compound. Therefore, if you put even if you put concentrated acid in sugar, it melts, it burns, and of course it turns black carbon. So uh, when the heat is high enough, they break down and decompose. These are few properties of the covalent compounds. Okay, let's look at covalent molecules. Covalent molecules are formed between molecules having covalent bonds, and usually these molecules are the one having electronegativity, small electronegativity difference. A chemical bond that involves sharing of electron leads to formation of covalent bonds. Okay, so to form covalent bonds, like a recap now. Number one, conditions that must be met, or factors that must be that affect the formation of covalent molecules will involve: number one, there must be presence of valence electron. Number two, there must be equal sharing. There will be equal forces of attraction between combining atoms for a covalent bond to be formed. That's another condition. Number three is that the ionization energy for both the atoms must be high so that electrons cannot be easily removed. The ionization energy must be high so that electrons are not easily removed. And then the approach of the atom towards one another will be accompanied by a decrease in energy. And then another factor will be that the atoms must combine together to form a covalent bond that must have equal electronegativity difference. So these are some of the factors affecting um, formation of covalent compounds. Please note that covalent bonds hold atoms together because the attraction between the positively charged nuclei and the negatively charged shared electron is greater than the repulsion between the nuclei themselves. So this attraction will make the molecule stable. So therefore, the strength of a covalent bond is determined by the energy required to break it, that is, the energy necessary to separate the bond. The strength of covalent bond is usually determined by the energy required to break it. Please take note of this, a very, very important point. Okay, so let's look at some other factors that affect formation of covalent compound. Another one is atomic size. The atomic size forming covalent bond should be smaller. Atomic size should be smaller. And then the electron affinity between these two atoms must be high. So high electron affinity, small atomic size, very small electronegativity difference, presence of valence electron, equal forces of attraction, and of course high ionization energy. So all these are uh, factors that determines formation of covalent compound, or factors affecting formation of covalent bonds respectively. So let's look at the various difference between ionic and covalent compounds. Of course, ionic and covalent compounds are compounds formed from ionic bond, while covalent compounds are compounds formed from covalent bonding. So what differentiates between them? In ionic, for instance, uh, the compounds are formed by transfer of electron from metal to non-metal. In covalent, they are formed by sharing of electrons between non-metal atoms. In ionic, there is strong electrostatic force of attraction between cations and anions. The cations are coming from the metal, anions from the non-metals. While in covalent, there is mutual sharing of electrons, and so there is a weak force of attraction between atoms. In Another one is that ionic compounds are usually solid at room temperature. Covalent can be gaseous, liquid, and soft solid, respectively. Ionic compounds can conduct heat and electricity, and covalent compounds, they are poor conductor or non-conductor of heat and electricity. Ionic compounds have high melting and boiling points. Covalent compounds have low melting and boiling point. Ionic compounds are soluble in polar solvent. Covalent compounds are soluble in non-polar solvent, except those of acids, like we have mentioned the other time. Ionic compounds are hard and brittle. Covalent compounds are usually soft and waxy. Ionic compounds Ionic compounds undergo ionic reaction which are fast and instantaneous, while covalent compounds undergo molecular reaction which are slow. So these are salient differences between covalent and ionic compounds. Now let's look at one question or two. In WIC 2011, the question says, what is a covalent compound? Give two factors that influence covalent bonding. You have to state the type of bond that exists in each of these: MgO, NH3, Fe, and then what are intermolecular forces. Please, can you do it to answer that question? Let's see how you are going to do it from what we have explained so far. Can you do it to answer that question? Okay, if you have attempted it, your answer should look like this. Covalent compounds are compounds formed by two atoms which donate equal number of electrons that are shared between them, so that each achieves a stable octet. Or we can simply play covalent compounds, or uh, covalent compound is a compound formed from covalent bonding, and of course covalent bonding involves sharing of electron between two atoms. So you can also put it that way also, but this is a good way to answer that question. We are now looking at factors that determines, we have mentioned about 5 of them the other time. We have mentioned about 5 of them. We have mentioned electronegativity, ionization energy, electron affinity, atomic size, polarity, um, and so on. And then of course forces of attraction between them. So these are factors that affect formation of covalent bonding. Okay, so we have to also mention um, the bond that this one carry. MgO is ionic or electrovalent, NH3 is covalent, Fe is metallic. Then what is intermolecular forces? Intermolecular forces are attractive forces that operate between molecules and influence the properties of substances. Okay, so let's do it to also look at another question. WIC 2008. WIC 2008. The question says you have to define covalent bond, give two properties of covalent compounds. With the aid of diagram, show how ammonia molecule is formed. You have to illustrate a diagram that help us in that illustrate the formation of a ammonium ion, and then we have to explain the type of bond that exists in ammonia and ammonium ion. So do well to attempt this question. Do well to attempt the question. Okay, if you have done that, this is how your answer should look like. A covalent bond is a bond between atoms in which each of the atoms contribute to the shared pair of electron. That's the definition of covalent bond. Then you have to mention some properties. They are not conductors of electricity. They are insoluble. They have low melting and boiling point. They do not conduct, and so on. We've mentioned that earlier. And then number 5, you are is expecting what type of bond exists in ammonia is a covalent bond. Then in ammonium ion is a dative bond or coordinate covalent bond. We are going to talk about that one soon. Then the other questions number 3 and 4 require that you show how ammonia is formed. This is how ammonia is formed in the diagram. You can look at how ammonia is formed here. You have NH3, one hydrogen atom each combining with a nitrogen atom, and of course in nitrogen, don't forget in nitrogen you have 3 single pair, three single electrons with a lone pair on it. So it will use 1 each to bond with the hydrogen atoms. So not to now form NH3. So this is how you should do the diagram. And then it also asks us to show how ammonium is formed. Ammonium is formed when ammonia combines with an hydrogen ion or a proton or an acid to form NH4 plus. We are going to be talking about that very soon in coordinate covalent bonding. So this is how the question is being expected to be answered. Now let's quickly go to coordinate covalent bonding. A coordinate covalent bond is also a type of covalent bond. In covalent bonding, we have the pure covalent bond and the coordinate covalent bond. And then under pure covalent bond, that's what we have talked about so far. We have talked about single, double, and triple covalent bonds. In terms of polarity, we have talked about polar covalent bonds and non-polar covalent bonds. And then additionally, I have said we could have homonuclear covalent bonding, because when they have when they are the same, like the atomic molecules, you have homonuclear, and then when they are different atoms like hydrogen and chlorine, you have heteronuclear covalent bond. So these are all types of pure covalent bond. Now we are looking at coordinate covalent bond. Coordinate covalent bond is one in which one of the bonding atoms donate both of the electrons to the bond. What do we mean by that? In pure covalent bonding, each of them are donating electrons for sharing. But in coordinate covalent bond, only one is donating electron for sharing. Only one is donating electron for the other atom donates nothing. An example is what we have looked at in formation of hydronium or hydroxonium ion. That's H3O plus. In this case, the H plus proton or acid, sometimes H plus symbolizes acid. The H plus wants to combine with water, but don't forget that in a water molecule, you have 2 lone pairs of electron on the oxygen atom. I think we have shown that before. There is 2 lone pairs of electron on the oxygen atom. So it is these 2 lone pair that will be combining with the hydrogen that is coming, the hydrogen ion that is combining, that is coming up. So you can see here that so it is this electron that it will be used to combine with H to form H3O plus. This is a type of coordinate covalent bond. Only one is donating electron for sharing. Only one is donating electron for sharing. We can go further to define a coordinate covalent bond. A coordinate covalent bond or a coordinate bond is a type of alternate covalent bond that is formed by sharing of electron pair from a single atom. Both shared electrons are donated by the same atom. So it is also called dative bond or dipolar bond. Coordinate covalent bonds are usually formed in reactions that involve two non-metals such as hydrogen atom, or during bond formation that exists between metal ions and ligand. Generally, it's always between coordinate covalent bonds are usually formed between um, two non-metals, or a metal having a lone pair and a one that is not having, and then of course also formed between a central metal ion and ligand in formation of complexes. So generally, when they say what bond is responsible for formation of complexes, it is a coordinate covalent bond. Okay, so some of the things you need to note under coordinate covalent bond is, in this type of bonding, the atoms that shares an electron pair from itself is termed the donor. Second is that the other atom which accept this shared pair of electron is known as the receptor or the acceptor. So in coordinate bonding, you have the donor and the acceptor. Number three is that the bond is represented with an arrow pointing towards the acceptor from the donor. We want to show that the bond or the electrons that are used for pairing is coming from the donor towards the acceptor. So we must show that arrow there. Number four is that after sharing of electron pair, each atoms get stability. Number five, getting a good understanding of coordinate covalent bond can help in properly design a complex organic molecule. Like I've said, coordinate bond help us in understanding complex ions, complex molecules, especially the organic complex molecules. Okay, so to form this type of bond, you must have a molecule with a free pair of electrons, and then something that needs to gain two electrons. For instance, H plus. Now, you observe that in the formation of um, ammonium ion, for instance, H plus means that it is deficient with one electron. So that means that one electron has been lost. So that's why you're having H plus. So if you add two electrons to it, for instance, you are going to have the other one replaced, and then you are going to have extra electron on it. So, and then in the ammonia, you are going to have a lone pair on nitrogen. So that means that there is availability of a lone pair of electron or a free pair of electron, and then the H plus is also needing to gain electron in order to be able to form positive, and that's why you will see NH4 plus on it. Now let's look at how it is being formed here. Formation of ammonium ion. Now you have a lone pair of electron on the nitrogen of the ammonia molecule combined with H plus. Now when you combine with H plus, you are having electron on each of the hydrogen atom has their own electron, and then they are also combining with one electron each from nitrogen that is being supplied, and then you have the electron that is lone pair that is remaining, that one we want to use to combine with the H plus. Then after that, after the intermediary, you observe again that the arrow is pointing from nitrogen to hydrogen. Why? That's the coordinate bond. It is what is used to coordinate the compound. The nitrogen, that means the nitrogen is now donating is two electrons so that it can use it to form a bond with the hydrogen ion. That is it. So that it can use it to form a bond with the hydrogen ion. How ammonium ion is formed. This is exactly how ammonium ion is formed. Okay, so you can get more. And then of course, like I've said, a coordinate covalent bond is used in forming complexes. What is a complex ion? A complex ion contains a metal ion surrounded by coordinately bonded ligands. A complex ion is a metal ion surrounded by coordinately bonded ligands. For coordinate bond is a covalent bond in which both electrons in the shared pair come from the same atom. And then what do we mean by a ligand? A ligand is an ion or molecule that donates a pair of electrons to a central metal ion. An example is what we see in this slide. You will see that you are having ion. All of them are pointing towards ion because they are donating electrons to the ion so that they can be bonded to the ion. Why the ions of the charge on that ion is taken outside. You observe the same routine here. The hydrogen ion H plus, the plus is taken outside to reflect that the hydrogen ion still have its plus there, and then it is now combining with the ammonia, and the electrons are supplied by the nitrogen of the ammonia. The same thing here, electrons are supplied by the ligands to the central metal ion so that they can combine together. So all these arrow that you see there is the arrow they are talking about the coordinate bond that is being used to form the complex. So in a typical complex ion, you have the central metal ion, and then which is the acceptor in this case, and then you have the ligand, which are the donors. So when you see something like this, you know that you have a coordinate covalent bond. This is an example of a cationic complex because it's having 2 plus on it. You could have anionic, and then you could still have a neutral complex, as the case may be. Okay, and a typical another example is what you are seeing here as well. Let's look at quickly properties of coordinate compounds. Number one, they have low melting and boiling points than the ionic compounds. Some of them show isomerism. Some of them can be isomers. They have the same molecular formula but different structural formula. Number three, another property of coordinate compounds is that there is sharing of electrons takes place in a definite direction. Hence, it is a directional bond because we are using arrow to point from the donor to the acceptor. So it give us a direct clue that this electron is coming from this bond to this bond. So it's a directional bond. It is also weaker than ionic bonding. It is weaker than ionic bonding. We can look at a comparison between ordinary or pure covalent bond and coordinate covalent bonds. These are salient differences. Covalent bonds are formed by mutual sharing of electrons. Coordinate covalent bonds are formed by it involves one-sided sharing of electron pair. Number two is that covalent bond, pure covalent bond, are formed between similar or dissimilar atoms. Coordinate covalent bonds are formed between two unlike atoms. Covalent bond may be polar or non-polar. Coordinate covalent bonds are always polar because it is formed between unlike atoms. They are always polar, either positive or negative. With a few exceptions to be neutral. That's for complexes, and that one usually occur in complexes alone. Okay, you can have another difference that involves shared pair of electrons that are donated by short lines, shared pair of electrons that are donated by an arrow. And then of course, covalent compounds are usually insoluble in water, while coordinate covalent compounds are sparingly soluble in water. So that's the difference between them. Let's quickly look at WAEC 2016. We have to list two factors that will favor formation of covalent bond and coordinate covalent bond. And the answer is for covalent bond. You have high ionization energy, high electron affinity, low electronegative difference, small atomic size, etc. For coordinate covalent bond, the factors include vacant or empty orbitals in one atom, presence of lone pair of electrons in the other atoms. These are factors that favor formation of this 2. Okay, we can also look at WAEC 2006 question 14, which is an objective question. They say what type of chemical body is involved in the formation of NH4 plus? It's supposed to be NH4 plus from a molecule of ammonia and a proton. When ammonia and a proton is combining, what type of bond are we supposed to have? You should be able to answer this question. If you have answered it correctly, we should have a coordinate covalent bonding. A coordinate covalent bonding. That's B as the answer. Okay, so with this, we have come to the end of this class. So far we have learned about covalent bonding, what they mean, the types of covalent bond that we have, the conditions for formation of covalent bonding, the properties of covalent bonding. And we also look at differences between ionic and covalent bonds. We have looked at covalent compounds, their properties, and of course we have also looked at coordinate covalent bonds, how they are formed, their properties, difference between pure covalent bonds and coordinate covalent bonding. So I hope you have been able to learn a lot from this lesson. Do well to take your past questions and other questions to solve more, to test or assess your level of understanding. Ensure you go through the slides again, and then of course continue to learn. Till the next time I come your way, continue to learn chemistry, and bye bye.